Hey everybody, welcome back to the Electronics Workshop. Another nerdy moment. So, I'm working on my AM broadcast transmitter that's going to work in the medium wave range, and I'm just kind of working through some of my circuit designs, and I figured I might as well tackle the lower voltage supply that I need for the local oscillator tube, as well as the audio vacuum tube, which I plan on using a 6SN7 for. It seems to be working very well. That'll be operating in Class A. Pretty much the rest of the amplifier will be running in Class A for the most part, so it's going to keep things nice and simple. But I do need regulated voltage for those vacuum tubes to keep both the stability of the circuit in mind, so that with voltage changes there isn't going to be as much drift. So in that case, I was digging through my inventory and I happened to find a 0D3, which is a gas discharge voltage regulator vacuum tube, and that'll actually fit in quite nicely with my design and how I'm planning to make and keep this thing into how it's going to look when it's completed. So it's in the rough stages at the moment, but the 0D3 vacuum tube is a 150 volt voltage regulator type tube. Looks like minimum plate supply voltage is 185 volts, so we're going to be well within that. Operating voltage is 153 volts, which is going to be perfectly fine for my circuit. Starting voltage to get the tube to actually arc and start regulating is 160 volt. It's offering, well, it looks like 4 volt regulation, probably some deviation capabilities, so plus or minus, I'd say 4 volts is the range. And it does show that a shunt capacitor maximum of 0.1 microfarad, so I'll be running a little capacitance on this. Might not even need it because the other circuits are going to be offering some filtering, so that'll be fine. They do have some notations here for the let's see here. There's a notation for the 0C3 and the 0D3 and D5 to a 40 milliamp. Let's see here. Oh, the 0B3 is 5 to 30 milliamps. So I'm just kind of looking over the circuit stuff here to see what I have to plan for. And we're working with a 0D3. So a maximum cathode current of 40 milliamps. So I think we'll be okay there. Average starting current is 100 milliamp max. Average time is 10 seconds maximum. So I think we're going to be okay here. Now, obviously, I do have some things that I want to keep in mind. I have to put a limiting or loading resistor on my B plus supply to keep things kind of a little bit more under control on the current draw, because basically what this regulator tube does is there's a gas charge inside of the tube that will ignite, kind of like a neon tube will ignite. Same idea. When this tube starts, it's going to offer a pull down resistance to maintain a consistent voltage and current through the tube itself. So it's essentially acting as a gas resistor in the circuit. So I can actually demonstrate that on the bench. I do have this set up on my awesome regulated power supply from Heathkit. So I can get up to or close to the 400 volts that my power supply that I'm building will be capable of supplying. It's probably going to be a little over that. I do have 10K worth of inline resistance to this vacuum tube. This voltmeter here will be showing the regulated voltage. This is the current being drawn from my B plus supply, and this will be the voltage that I'm giving the regulator tube. So I don't know how well you're going to be able to see all of this, but I will just call out the numbers as I see them. So we're starting right now on 0 volts, so we don't have anything going on there. Let's go to the 600 volt scale, and we're already doing about what, 5 volts because it's on ish. So let's bring this up, and we'll take it up to about 50 volts. So you're gonna see the B plus supply voltage pass right through this tube without any regulation or restriction up until it actually arcs the tube. So we'll take it up to 100. Again, we have no regulation coming in play because the B plus supply has not come up to that point where the tube is arcing. And then we'll take it up to 150. Now this tube is rated for 150. It's still showing I'm not drawing any plate current, so we're actually not arced yet. These glow kind of a fun, like a pinkish purple color when they're actually regulating. So I should be, once I get up just past 150, I should see the current come up. 154, 155. We're regulating right now. We don't have much going on, but I can tell that I'm over my start voltage, and now we're going to start seeing the current start climbing. We're at 200 and, well, we'll just take it up to a nice round number, 250 volts right now. We're still regulating at 150 volts. Looks like we're drawing about what, 5, 10, 15, 20. We're drawing about a little over 5 milliamps at the moment. We're at 300 volts, still regulating at 150 volts. Let's take it up to 350. Still regulating at 150 volts. We are at 5, 10, 15, probably close to 16 to 18 milliamps of current. And I'm going to just top this out at where it goes to the maximum. And we are close to 400 volts, probably just slightly under. And we're regulating at 149 volts. And we are just under 25. We're in between 25 and 20, so we're well within the range of safety to keep things happy. So it's under that 30. Now these resistors are absorbing a lot of that heat, a lot of that energy that we're clamping down on this tube. So these are going to get warm. So I need to size these appropriately to maintain a good heat range, so we're not going to thermally absorb them, cause the resistors to fail. But I figured at about 10 watts worth of resistor at about 8,500 ohms will be plenty to do it. They're going to get warm, but sandbar resistors are kind of designed to handle that. I might go a little overboard and see if I have something in the 25 watt resistor range, but I'm currently using a pair of 5s in series, 5,000 ohm resistors in series, and it's actually cooperating very well. I really like that. That's pretty much exactly what I wanted. They're not getting too terribly warm, so that may be my ticket. Those might be the resistors I use. The vacuum tube has a very pretty kind of a pinkish purple hue. Let's get you in there and see you can see it. So if you're looking down on the tube, let's turn off the light. Sorry about this. You can see that pink kind of purple hue shining through from the discharge. And if we shine maybe down, you'll be able to sort of see how that's working. And it works identically to like a neon tube on how they have a start voltage. So that is, watch your eyes, there we go. So that is how gas tube regulators work. They're calculated in their design. They work incredibly well. Again, vacuum tube, they're probably not the most efficient because we're pulling a lot of that heat away on these resistors, but if sized appropriately, they can be, there we go, turn that off. If sized appropriately, they'll work out quite well. So hope you found this fun, nerdy, informational, educational, and everything in between. And because it's nerdy, I enjoy it, and I hope you do too. So thank you for joining me in another nerdy moment, and maybe the next videos you'll see, I'll actually have the hole punched out for this particular tube and kind of wired in so that we can see how it works in the initial circuit power supply design for the AM transmitter. Catch you in the next video.